Okay, welcome to another video. In this circuit we are to find DE, that is differential equation relating a V1 and a V2 of t in the figure below. So in this circuit we are having all the three circuit elements, that's resistor, the capacitor and the inductor respectively. So we are going to solve it by applying the same procedure that we did in the previous video. We are going to take a KCL of each loop. So here we go. So we say by taking loop 1, this loop across here, we can say a V1 of t, right, minus then V2 of t must be equal to this circuit element, this resistor, voltage across this resistor and voltage across this inductor. So the voltage across this inductor, we will say the voltage across this resistor will be equal to the resistor times the I, that's I of t, that's the current flowing across the mesh, then plus for the voltage for the inductor is given as L di dt. So this one is equation 1. By taking mesh 2, that's mesh 2, you can see this mesh 2, call it mesh 2. So we can say the V2 of t is directly equal to the capacitor element, and the voltage for capacitor is given as 1 over c integral of I, that's 1 over c integral of I dt, I of t dt. Then from here we can make I subject. We can say I of t is equal to c dv2 dt. So this one is equation 2, this one is equation 3. So we are going to take equation 3. Since we are to find the relationship between a V1, that's V1 and V2, so we are going to substitute this I. We are having I in terms of c dv2 over dt, so we are going to put equation 3 in equation 1. Putting equation 3 in 1, we can have b1 of t minus b2 of t is equal to I, in parentheses we have I as c dv2 dt plus L d, we have I d dt, we have I as c dv2 dt. So here we go, we can say b1 of t minus v2 of t is equal to, if you open this parenthesis, we have rc dv2 dt plus, since this one is derivative times another derivative will give you a second derivative, then we have, that's L times c second derivative of v2 dt square. So from here we can arrange the equations in in ascending order. We can say d square b2 dt square, then we have LC here, plus RC dv2 dt, then plus v2 of t is equal to v1 of t. Yes, so this is the final answer, or let's say the final solutions which relate v2 and v1, and this is the second order systems. This is the differential equation of the second order. So this, don't forget to subscribe as Calitronics, share it to others. Thank you for watching.